Hello everyone, my name is Anvita Bansal and we are back with another lecture based on stacks and queues. So the problem that we are going to discuss today is, let me show you, stack using two queues. So this is your problem right here. Okay, let me just take this off. Okay, so what does this question say? Almost vice versa of what we did yesterday. So we implemented queue using two stacks. So if you have already watched that video, then obviously this is going to be way too easier. Otherwise also this question is easy. So I'll explain to you what you have to do in this question. Before that, I'll check if we are live. Yes, I think we are live. Fine. So let's start off. We have to implement push and pop operations of a stack but using two queues. So we are already given queues of type linked list here. So we have to make use of these two queues and implement stack operations which are push and pop. So let's have a look how can we do this problem. First of all, how push and pop operations on a stack look like. Okay, so let me draw a stack for you guys. So what does a stack follow? As in, the pattern that stack follows while pushing and popping the elements is last in, first out, LIFO, right? We all know that, we have already discussed in the previous lecture. If I give you operations like push 1, then I ask you to push 2, then I ask you to push 3, how is your stack going to get filled up? So first we push 1, then we push 2, then we push 3, then I say pop. So which element will be removed from the stack? The element which we just recently pushed, that is last in, first out. So I will get rid of 3. Now let's say I say pop again. Which element will be removed from the stack? The one at the top of the stack, which is 2, right? And so on and so forth. Let's say I say push again, push 4. So 4 will be pushed. Now your stack contains 1 and 4. So basically you have to implement this data structure without exactly using a stack but making use of two queues. So how does a queue perform these operations? So we very well know that it follows FIFO, that is first in, first out. So I have two queues, Q1 and Q2. Now tell me, what can we do? If you have gone through yesterday's video or yesterday's question, I think you'll be able to guess this immediately. The intuition is also very simple behind this, that what we want is whichever elements I push, okay, if I directly push into my stack and then I call for a pop operation, which element will be removed from this queue? You know that queue will remove the element which I entered in the very first place, that is first in, first out. So if I call a pop, 1 will be removed. But on pop, you all remember when we were pushing 1, 2, 3, and let's say I call a pop, so actually 3 should be removed from the stack if I'm implementing a stack, right? But in this case, if I simply do a removal from a queue, then I will not get 3 because 3 was recently pushed, and a queue will always remove the element which was entered into it in the most beginning, right? So that is why I'm going to make use of another queue, so that the element that I want to pop, element which is supposed to be popped, supposed to be removed, should be in the beginning of a queue. That should be my aim. First place, you can say, first place in queue. So in order to make this thing happen, I am going to make use of second queue. You got this point? So basically a queue will only remove the element which is found in the first place, right? So like for example in this case 1. But since I want to implement a stack, if I am pushing 1, 2, 3 in my stack and calling a pop, so pop will remove 3. So let's do one thing. In your queue, make use of queues in such a way that you get 3 in the beginning of queue. Whichever queue you are using, that's your call, where you want to do operations in such a way that the element that you recently pushed into your queue is found in the beginning of the queue. So how can we do this? So let's see this example. So let's say you have to push 3 elements, 1, 2, 3. Okay, push 1, push 2, then you are pushing 3, and then you are doing pop, then you are doing pop again, then you are pushing 4. So this is what you have to implement. So this pop should give you, when you have pushed 3 elements, so according to stack, this pop should be returning you 3, and this pop should be returning you 2, and then you're pushing 4, and that's what we want. Basically, I want the returned elements of pop to be equivalent to 3 and then 2. So let's see what we are going to do. When I am pushing 1, right now my Q1 is empty. Okay, so I am pushing 1 in my Q1. Okay, now I want to push Q2. So I will make sure that the element that I am recently pushing gets into the beginning of my Q1. So for that I have to empty Q1. Empty Q1. So push all the elements from Q1 to Q2. Let me just remove this. See the steps. Just take care of the steps, and then it's very simple. What I'm doing, in order to push, this is your push operation going on. You will first empty your Q1, then push all the elements from Q1 to Q2. Now the element that you want to push it to Q1, add the element, add to Q1, add X to Q1. Now the elements that you push to Q2, move them back to Q1. So bring elements from Q2 back to Q1. So let's follow these steps and have a look. So when I was pushing 1, I saw my Q1 was already empty. So I don't need to empty 1, and the rest of the steps will also not matter now. Now I'm pushing 2. So when I'm pushing 2, in stack, it should be like this. Now what is happening? It is first step says empty Q1. That means you have 1. So you push this 1 from Q1 to Q2. Now next step. Q1 to Q. Okay, first you empty. So basically this 1 and 2 steps are equivalent only. So for explanation I wrote that. So it is your 1, 2 and 3 steps. Typically 3 steps you are performing. Elements that are present in Q1, you move them to Q2. Now the element that you want to add, that is X, this is X, here is 2. You push it to Q1, right? I pushed my 2 to Q1. Now the elements that were pushed to Q2, move them to Q1. So this one will be removed and this one will be added here. Now your Q1 has 2 and 1. Okay. Now let's talk about another element, that is 3. So again you are doing what? Move the elements from Q1 to Q2. When you move elements from Q1 to Q2, what must be happening? Elements are removed from the first position of a queue. So first 2 will come here, then your 1 will come here. This is how Q2 is going to look like now. Now you, second step, add X to Q1. So you are adding element number 3 to Q1. Now move all elements from Q2 to Q1. So Q2 will get rid of 2 first, then it will get rid of 1. And that's how your Q1 must be looking like. So right now your Q1 is 3, 2, 1 and Q2 is empty. Whenever we are pushing the elements, these are the steps we are performing. Now I want to pop. So we have maintained 2 queues in such a way that Q1 is always going to have the element in the front of its queue, which ideally should be removed from the stack. Now if you do Q1 dot remove. So since in our question Q are of type linked list. So linked list use this method remove to remove the element from the beginning of this queue. So what is present in the beginning of this queue? 3. So when I call pop operation, I should actually be removing the element from Q1, because that is how I have maintained the queues, that Q1 is always going to have the element in its front, which ideally should be removed from the top of your stack. So this Q1 dot remove will return 3 to me. Okay. Now 3 has been removed from the. Now I am calling pop again. So pop again will go. This is your pop operation. Pop operation will do only this thing. It will return Q1 dot remove. Now Q1 has 2 in its front, so it will remove this and 2 will be returned to your pop operation. Now your Q1 is 1 and Q2 will remain empty. Okay. We are only filling Q2 as a, you can say, temp q, like we when we do the swapping, we take a temp variable. Similarly, you can take this as a temp q, in which you are pushing the elements so that the element that should be at the top of the stack can come in the front of q1. That's all. Now you're pushing p4, so you're repeating the steps again. You move elements from q1 to q2. Right now you have only one element, move it to q2, then add that x element to q1, which is element 4. Then move all the elements from q2 to q1. So q2 only has one, it will be moved here. Now if I call, let's say, pop again, so pop will go ahead and call q1 dot remove. So q1 will be removing 4. So ideally 4 should have been removed and 1 is still present. That is all about this problem. So in this problem, we are actually making our push operation costly. Can you see these steps? So the elements that are present in q1 are being moved to q2, like I told you, like a temp q it is. Then you add your element that you want to add to q1, and then all the elements from q2 are brought back to q1. So it typically takes O(n) of time complexity, right? Because you're doing q1 dot remove and then you're doing q2 dot remove, so basically it's typically 2n, but I can consider it as O(n) because it's your n is actually going to be less than the total number of elements that you are pushing until it reaches n. So you can predominantly take it to be O(n), and space complexity is also going to be 2n basically, but we will be taking predominantly O(n). So this is how we are making it. We are making these operations take place, and we have made push operation costly. Pop is happening in only O(1) of time complexity, as we are only making call to q1 to using the method dot remove. So dot remove method will remove element from the front of q1 in O(1) of time complexity, right? Let me just check if you guys have any doubts. Hello everyone. Hello Gagandeep. Hello Shubham. So I hope the problem is clear to you guys, and if you have any doubts you can write me in the chat. And now I'm going to begin with the code part of this question. So this question, as I said, it's very simple. Just that, if and even more simple if you attended yesterday's lecture. So that was all about this problem from explanation part. Now if you're clear with the explanation, I can move ahead with the code, which is going to be even simple. Very simple code. I actually wrote it in the steps, so let's see. Since we are making push operations costly and your function is already, your class queues already has these q1 and q2 declared for you, so you don't even have to create them. We will simply, while we are pushing, we will check until your q1 becomes empty. q1 dot is empty. Okay, you are moving all elements from q1 to q2. So q2 dot, and since it's a linked list, so I will be using methods that are used in the linked list. So how do you add element in a linked list? By using dot add method. So q2 dot add, and you're removing from q1, it uses remove method dot remove. Okay, next thing is, once you have moved elements from q1 to q2, you add your original element into q1 so that it can come in the front of q1. So q1 dot add this element a. Fair enough. Now all the elements that were pushed to q1, that the elements that were pushed to q2, I am adding them back to my q1, right? So just making these q2, this will become q1, this will become q2. That's all. Okay, so a push operation has been done, and for your pop operation you are doing nothing. If your q1 is not empty, if your q1 is empty, return -1, else otherwise you return q1 dot remove, as I told you. Let's submit it. Done. We are done with this problem. You guys can have a look at the code. I will meanwhile check if you guys have any doubts. If it is clear to you, we will wrap it up. Okay, so you can have a look at the code meanwhile. I'll give you 1 or 2 minutes to see if you still have any doubts. my voice was audible and there was no issues in the audio. Good, good. If it's clear, then let's wrap the question up. It was an easy one. Wouldn't even take much time even if you try to do it on your own. So, okay then. See you all in the next lecture, that is tomorrow, same time. Try to do it yourself, everyone. If not, you can always come back to the video. Okay then. Thank you, everyone.